composition, so we're going to talk about operations first. Again, should be a review. Okay, we've already done polynomial operations. Matthew, put that away. The only difference now is that our exponents are fractions instead of whole numbers. Okay, but as far as the operations, they stay the same.
Yeah.
What?
We just did that.
No, we're doing addition, subtraction, multiplication, and composition. We're not going to focus too much on
How did
division.
you do that? The last one? The adding one?
Goodness, thank you.
You've got caught.
Sorry, people watching the video, I forgot to hit record. We're adding and subtracting.
You've been caught, God.
All right, so
YouTube.
f of x is 4x to the 1/2. G of x is negative 9x to the 1/2. So now, what, Ben?
Oh my God. Why can't it
It hasn't been x since we started Algebra 2. All right, what is f of x plus g of x? How would I add those two functions?
Well, add the frag.
So let's think about it. We can only add what? Like terms. So let's rewind. What does it mean to be a like term?
Same.
Like term means same base and same exponent. Same exponent. So are those like terms if I have 4x to the 1/2?
The base is 4.
Those are the coefficients, Ben. The base is x there. It's what's hooked, the exponent's hooked to. So now my question is again, are those like terms? Yes, so to combine like terms, we combine the what? Coefficients. We leave the base and the exponent, so we get negative 5x to the 1/2. Easy peasy?
Wait, I just got fish right in the middle.
Okay, no, that's fine. What if I asked you what f of x minus g of x is? So what do you do now?
Subtract 4 from 9.
Negative.
No.
You can minus negative, well, it would change. So you got 4x to the 1/2 minus negative at 9x to the 1/2. So now,
Same change.
yeah. So what would it become? It'd be plus 13. Now, if you need me to spend any more time on adding and subtracting, they make it a little bit more complicated, a little bit longer, and you have to find the like terms, but we've done adding and subtracting. You're just picking out the ones that go together, yes?
Yes.
Can we all handle that? Speak now, forever hold your peace. Okay, let's do multiplication. The composition's going to be, and it's not new, you've done composition before, just not multiplication.
Is part of the last thing we just did?
Let's redefine f and g. I don't think so. I think this is a fairly easy chapter.
Okay. Like chapter or section?
Oh, you thought the first section was hard, the
I think
exponents?
Wait, was that the first thing we just did?
Mm-hmm.
I mean,
That was 3-1 and 3-2. This is 3-3.
So what's 3-1? And what was 3-1?
Right, nth roots, rational exponents.
Well, we just took a quiz.
What you just took a
I
quiz
thought
on.
it was 3-2.
3-1, 3-2.
Let's say now I've defined this f and this g. Okay, I'm not adding anymore now, I'm multiplying. So if I asked you what is f of x times g of x, and I'm doing kind of easy examples, some of these might involve you distributing, but it's the same concept. I just kind of want to, composition's where I really want to focus today. If I multiply these together, remember, when we add, we combine coefficients, we leave the base and the exponent. When we multiply, what do we do? Add the exponents. We multiply the coefficients, we add the exponents. So this becomes 6x to the what? 7/4.
Wait, how'd you get 7/4?
This is a 1, right? 1 plus 3/4.
Oh, you add.
We need to do
which is 4 over 4 plus 3/4, which is 7/4.
Wait,
Again, are we getting caught up on the fraction
Yes.
part of it?
very much so.
I wouldn't have done that.
Okay, so if you would not have done it,
I wouldn't have thought about it.
I can't, like, I don't know what's wrong with me.
let's see. Would you have,
Oh, goodness.
where's my Remember I showed you how to do this on your calculator? So you'll do 1 plus 3/4, and then you do math, enter. Yes?
Yeah, but I just don't. How
Decimals are so much
do you get
better.
7 if you're adding 1?
Well, 1 is the same thing as 4 over 4. We have to get a like denominator.
Then when you figure out how to get a
You probably
get a
would do it
PS4
when
and
you
bigger goes like this, we could screen it, or actually then.
Remember, when you add or subtract fractions, you must have a common denominator. You also have a calculator that does this for you.
Wait, Miss McGee. So let's say that was
Sean, oh, I didn't have that recorded. Say it again. What if I divided?
subtract the exponent.
Subtract them exponents. That's exactly right. So if I take the exact same f and g, this time I'm going to divide. So I'm going to change this.
Oh wait, oh man, I'm trying to see it.
So I have 6x over x to the 3/4. What is 1 minus 3/4? Come on, guys. What is it? 1/4. If you have a whole pizza and you take 3/4 of it away, you're left with 1/4.
Wait, Miss McGee, for the last one, I'm trying to write down the answer. It ended up being 6.
Composition. All right, I'm going to start out with an easy f and g. Let's say 2x squared plus 3, and g of x I'm going to let be x minus 5. Now, composition is whenever we take one function and plug it into another. So let's start out easy. If I asked you first to find f of 2, tell me what you would do. Put 2 in for x, Matthew. Whatever is in parentheses here is what you're subbing for x, right? So this would be 2 times 2 squared plus 3. Square it first. This should be old review for you, yes? Okay. But what if I changed this a little bit and I asked you to find...
Wait, they would give us that too.
Yes.
But it says x equals 5 over there.
I asked you to find this based on what I gave you in the blue. Shh. What if I asked you to find g of f of 2?
So you plug in 11 for f.
Okay, understand what it is I'm asking you to do. You have to work inside out with these, okay?
Multiply those two.
What is f of 2?
11.
11. We all agree with that? So really what I'm finding is not g of f of 2, but g of 11.
So you can't figure out one unless you've done that.
Exactly, when we got
Wait,
numbers like
you don't do
this.
anything with the 2, it's just g of 11.
We've already done it over here.
Okay.
So g of f of 2 is 6. Okay? The key here is going to be to work inside out. So I'm going to work, let's do a few examples just with the numbers, and then we're going to actually plug the functions into each other. G of 11, I put an 11 in for the x and g. All right, stop it. Hush, guys. Let's do, I'm going to write these same ones up top. F of x is 2x squared plus what?
3.
3. And g of x is x minus 5. What if I asked you, let's do one from the beginning. Let's
These are
do,
different problems.
I'm going to do some examples. Let's find f of g of -3. Okay, inside out. The key to these is inside out. What is g of -3? Well, you plug in -3. G of -3 is -3 minus 5, which is... So now I'm not finding f of g of -3. What I'm really finding is f of -8. Yes, ma'am. Yes, this is what your problem, it'll give you f, it'll give you g, and then it'll say find f of g of -3. Yeah. Be careful when you're plugging in, especially when you have squareds. You have to do exponents first, right? Right.
Right.
So this would be 2 times 64 plus 3. Don't do 2 times 8 and then square it. Square the 8 and then times it by 2. So I got 128 plus 3, which is 131. How about this one?
Can we do this from by ourselves?
Yes, try this one by yourself.
Crap, can I get these baby and put some in, please? Oh, no, I gotta put some in. Never mind, I got one.
All right, let's inside out. So just look at the inside first. What is f of -1? F of -1 is going to be 2 times -1 squared plus 3, which is 2 times 1 plus 3. You're right, which is 5. So now I'm not finding f of -1, I'm finding f of 5, which is 2 times 5 squared plus 3, which is 2 times 25 plus 3, which is 50 plus 3, which is 53.
So you don't do anything with the G?
Nah, man.
No.
You don't always use all of them. You use whatever it's telling you to use. You look at the letter outside and see which one you're supposed to reference. Yeah.
What?
I'll give you a second to... Ooh. What I want you to understand is it doesn't matter what's inside the parentheses. F of cat. It doesn't matter what's there. Whatever is there is what's replacing the x. Do you see what I'm saying? And I will simplify as I can. Okay, so what if I asked you to find g of x plus 1? You plug in, yes.
Is it? Is that
No.
just unrelated?
No, that's completely unrelated, yeah, yeah. All right, so I'm gonna take g, but instead of x, I'm gonna have x plus 1 minus 5. Do you still see the g equation there?
Yes.
G is x minus 5. In place of the x, I'm putting x plus 1. So I could simplify this to x minus 4. What if, though, I took the same one and I said, what is f of x plus 1? This one gets a little bit harder. Why is this one harder than the other? You got a squared there. Everything stays the same except the x. So 2x plus 1 squared plus 3. I literally, if I could reach in and take the x out and throw something else in there, that's what I would be doing. But here I can't just I did not just say distribute. Distribute that squared through, right? I have to instead do what?
Square or something?
Well, how do you square a binomial? Distribute how? FOIL, exactly. Distribute, like write it 2 times and distribute. It doesn't matter which ones. Remember, when we're multiplying more than 2 things together, it doesn't matter which 2 you do first. Pick 2, do them, and then take them to the third one. Okay. Which two you want to do first?
Just the two parentheses.
Two parentheses? Okay. The two binomials. X times X is?
X squared.
X times 1 is? 1 times X is? 1 times 1 is? This is 2 times X squared plus 2X plus 1. Now what?
Multiply by 2.
Distribute that 2 through. 2X squared plus 4X plus 2.
Plus 3. So it's 5.
So it's 5 on the end. That's exactly right. So it's 2X squared plus 4X plus 5. It's easy. Okay. Using the same F and G,
This happens to be the last one, but it will be the
2X squared plus, did I say 3? And G of X is X minus 5. Let's see how easy it is. What is F of G of X? What am I doing? What am I plugging in where?
You're plugging in X, X equals G.
I'm taking whatever G is, which happens to be X minus 5, and that's what I'm plugging into X.
Oh, okay.
Okay? Understand what I'm doing? It's the same. Ben. I'm doing the same thing that I did before. This time I'm just referencing the inside by its name. Okay, so now it's 2x minus 5 squared plus 3. Does that make sense to you? This is 2x minus 5, so I'm going to FOIL this out quickly. X squared minus 5x would be minus 10x plus 25. We just did this, is why I'm going quickly through this, because I want to show you one more thing. X plus 50 plus 3, and I'm going to get my like terms together here. I'll give y'all a chance to copy that down. Is anybody confused on that? Okay. How about if I asked you to find, y'all ready for this?
Sure.
Oh, you just plug in. You just plug in X minus 5.
Exactly. It's just G of X minus 5. Shh, guys, it doesn't matter that it's the same thing. It's still what I'm plugging in for X. So it's X minus 5. Tell me what you think about function composition.
It's easy.
Easy?
It looks
I'm
No.
good. Let's see. No calculator. I'm good.